Well, this is a video about artificial intelligence, genetic algorithms, and we are going to speak about a technique called fitness sharing. So, it is the concept of sharing in nature. It is common because the natural resources for a given species are limited. So, when the resources are scarce, conflicts between elements of the same species may arise because they compete for the survival. So from this competition emerges an equilibrium between the risks associated with the fight, and this induces the sharing of the resources among the population elements. This is a topic of research. For instance, this is an article published in this journal, Behavioral Ecology, with the title "When Should Animals Share Food? Game Theory Applied to Kleptoparasitic Populations with Food Sharing." So this is a well-known topic, and this topic was inspired Goldberg and Richardson in 1987, sorry, for to propose the sharing function within genetic algorithms. This is the article. It was published. This was within multimodal function optimization. So this function allows to evaluate the degradation of a given individual fitness due to the presence of other population individuals within a certain distance. I'm going to explain what the meaning of this is. Uh, so the distance between the individuals may be evaluated using different metrics. So I'm going to provide here an example of a simulation where we got just this function, and the objective is to find the maximum. So the maximum is here, and so the population is the size is 100 elements. The crossover probability is 0.75. The mutation probability is 0.01, and we are going to run it for 100 generations. So this is the outcome, and as you can see, the mutation here, the red spot means that we found the maximum, and there's some diversity because of the mutation. So if you run the same simulation, but now with the mutation probability assigned to 0, as it is in this, as it is here represented, let's see what is the result of the simulation. As we can see, all the population converges to the global maximum. Okay, so no elements of the population goes to this peak and goes to this peak. So this is the objective of the paper from Goldberg, is how to promote the exploration of niches in other regions of the search space. And for that, they proposed a fitness sharing function, which is this one based on the distance. So if the distance between two elements is 0, if they are in the same point, so the maximum value from the sharing is given, which is 1. If they are within a range, a radius, which is this sigma s, the sigma from sharing, so there is a formula where the distance between the elements is divided by the sharing radius, and there is a constant here, alpha. Usually, the distance is can be an Euclidean distance between the two elements, and alpha is a constant, and also the radius is a constant. So this means for instance, for this example, that I want to penalize like these guys. They are in the same peak or in the same region, so I'm going to consider this in this case is just a small distance, where if they are in this radius, I'm going to penalize them. Okay, so this is an example where the radius of a linear function. So this a is equals to 1, and this is the distance, and we can see here that the maximum sharing is 1 when they are at the same point, and it is going to decrease until the radius, which is 20. After this, or out of this radius, there is no penalizing from the fitness. Okay, so so after you evaluate this sharing between all the individuals, so you the way that you can penalize the function, the shared fitness is this one, which is the division of the fitness by the sum of the shared values. Okay, so I'm going just now to show you the result of the same example with fitness sharing, where in this case the radius is really small. The sharing radius is 0.01 because this is just between just one variable between 0 and 1. So this means that they if we want to penalize the elements in the same peak. Okay, so what is the result? And as you can see here, there is elements exploring the one peak and the other one. So we force the population to explore this second peak, okay? And with the proper tuning of this sharing radius, maybe you can also explore the third peak, which is what is going to happen if we consider this sharing volume of 0.09 in this case, okay? And as you can see here now, we had like elements in the one third. Okay, they didn't reach the third peak, but at least they are exploring the third peak. Okay, we could go on because there's a smaller peak, but this is not significant to be detected by the GA.